Hello everyone. This video is the another part of NLP series which going on. And if you haven't seen my previous video, in my previous video I have discussed and talked about the feature extraction which are used in NLP pipeline, like what is bag of word, what is n-gram, different version of n-gram, and how to build a project around bag of word using n-gram in machine learning, right? So this video I will talk about another technique which are used in NLP extraction is called TF-IDF, right? It's very important, one of the important technique which are used in NLP. So what is TF-IDF? What are the importance of TF-IDF and how to use it, how to build a model around it? This all thing I'm going to cover in this video. I hope this video will add a lot of information. Okay, so please watch it and let's get us started. Let's understand how to use TF-IDF in the given NLP pipeline. So let's get us started and let's understand TF-IDF in detail. If I talk about what is TF-IDF, okay, so it is called, you can see that it is called term frequency and inverse document frequency. So it has two components. Let us understand why we have two components and what are the importance of all the components. Okay, so if I talk about in a nutshell, if I summarize, so TF-IDF talks about, let's suppose you have given a corpus, suppose you have multiple sentences, right, and you have a lot of text in that. So it try to find that how important, I repeat, it is try to find that, okay, how important a word is in a document. Okay, so it try to find the importance of any word in a given document. I will give example right now. So let's suppose we have a corpus, a given document, so it will try to find that any word, okay, suppose there is some any word, for example I'm using tasty, I'm using pasta in my previous example. So any given word in a document, how these words are importance, what are the importance of that word, that measures this technique TF-IDF. Okay, so this is a numerical statistics technique. It is based on stats. Okay, it is not a neural network kind of technique, which for example word of week. Okay, there's another technique called word to week, which is it 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 captures a lot of semantic meaning. I will cover later. So word to week model, it is based on neural network, right? But this technique TF-IDF, it is based on statics. Okay, so it's a numerical statistical technique used in NLP uh, to perform how important a word is to a document in a collection. Okay, so it summarizes that how in a given word are more important, what is the weight of a given word in a given document, how to calculate the weight, how to find the importance. That's a mathematical there's a mathematical formula. I will cover that. But in this is the whole intuition. It try to find the importance of any word. If somebody asks in interview what is TF-IDF, your answer should be it try to find the importance or weightage of a given word in a given document. Okay, this is how the intuition. I will talk about in detail. So it is where is the application of this whole this technique, this model. Okay, it is generally used in text classification. Whenever you have a, suppose you're building a machine learning model like sentiment analysis, generally we do sentiment analysis, like, or we have to classify, suppose we have multiple category, right, like a spam problem, like ham problem which I solve, whether this email is a spam or not a spam, something like that, where you have to classify typical classification problem. You can use this technique. Okay, keyword extraction, this is also very used, and document similarity. Okay, this is and this is one more thing, guys, this is also used, this technique is also used in the RAG application. Okay, RAG application, if you have idea about RAG application, so RAG application is where we ingest a lot of data, a lot of document in our vector database, right? And given a query, we find the right document. Okay, we find for a given key, we find the right document, and this document we send our LLM to give a response. This is a typical RAG pipeline. So in the RAG application also, this technique, along with that, we use BM. There's another technique called BM25. Okay, this is very similar to TF-IDF. So this technique we use to find the relevant document. Let's suppose I have a word, suppose testy, right? So this word testy in which document it is appearing most time, right? So given a query, suppose the user has given this query, I want some tasty items. So this is the query, I want tasty item from this restaurant. So tasty word, right? So in the given document, how, in which document this word, this keyword is more relevant. So this way, this model will try to find that this word in which document it is more present, or this word has importance in which document. So in the document search or the document similarity search, or if you know the RAG application, right, cosine similarity, those things, okay, if you want to find the relevant document which this document contain that keyword, if you want to do that kind of keyword search, okay. So RAG has two types of search, okay, it's a RAG concept, I don't want to go in that detail. So RAG has two types of search, okay. One is called dense search, which is based on vector database, and one is called keyword search, okay. So in the keyword search, suppose you want to implement keyword search in your RAG pipeline, then you can use this technique, and like along with VM25, and this can be one application, right? So yeah, these are some couple of applications where you can use this technique called TF-IDF. Okay, so let me explain the intuition behind that. I just talk about, right, what is TF-IDF. So it finds the importance of any word or weightage of any word in the given document. This is the whole intention. Okay, so if I go deeper, so it has two components. I just discussed. It has one component is called term frequency. It is called TF, and another is called IDF. It is called inverse document frequency. You might be wondering why we need two components, why we need TF and then plus I need IDF. I will discuss about that, okay? But it has two components. Why we need two components? Let us find out, or to discover in this video. So the first term, which is called term frequency, it is from the name, it's, you can see that its name itself, it is defining term frequency, okay. So it talks about that it is try to find the frequency of given term in the document, okay. I will explain given with the example, but let us understand the definition first. So the first definition, term frequency, it try to find the frequency of a word in a given document. Suppose we have multiple documents. For example, here, let me give this example. Let's suppose I have three documents, okay. Let's suppose this is my first, I'm calling review one. It is also called review one. So I'm calling it, suppose this is my first document. This is my document one. This is my document two. And this is my document three. It is also called review, document or review, okay. So let's suppose I have three documents, right? So testy, for example, I want testy, right? So testy words, okay. If I talk about TF, what is TF? What is TF? So TF will try to find any word or any keyword, for example, testy keyword, how many times they are repeating, or what is the frequency of that word in a given document, okay. So if I say that I want to find the frequency of testy word in a document D1, so how many times it is repeating, you can see that it is repeating one time in document D1. It is this keyword is coming one time, just single one time, right? For example, this testy is coming in this document one time, right? Test is coming one time, right? Suppose if I say pasta, how many times this pasta is coming in document? So in document one, its frequency is one. In document 2, the frequency is also 1. In document 3, frequency is 1, right? Suppose restaurant, if I take this keyword, restaurant keyword. So if I ask you, okay, tell me for this keyword, restaurant, what is the frequency in D1? Okay. So for keyword restaurant, what is the frequency in D1? So you can say in the D1, this keyword, there's no representation. It's a 0, right? So I can say that the frequency of restaurant in D1 is what? 0. If I say in D2, what is the frequency of restaurant keyword in D2? Again, 0. There's no keyword restaurant in D2. If I say in D3, in document 3, what is the frequency of restaurant keyword? Just 1. It is appearing the first time, one time, it is 1. So this way, we find the frequency of each word in a given document, right? So Okay, so why we're doing that? Okay, so with doing this, by finding the frequency, I will find that which word is repeating more time. Okay, for example, you can say that here this. Let us see this word. Okay, let us focus on this. Okay, this word, this keyword here, this keyword here, this keyword here. Okay, if I ask you for this keyword, okay, for this keyword, what is the frequency in D1? 1. What is the frequency of this in D2? 1 1 1. Okay, in D1 is one frequency, you can see that this keyword has more frequency. I mean, this word is repeating more time. It is called most frequent word. Okay, it is called most frequent word. It is repeating more time. Okay, but the frequency of restaurant is less. It is just repeating one time. Okay, it is called rare words. So there are two things. One is called rare words, okay, and one is called frequent words. Okay, so this with this term frequency, if I prepare a table, okay, if I prepare a table like this, if I prepare uh, a table, and in this table, if I find that for the given word, what is the frequency, right? So this way it will give me the idea, intuition, that this word is more important, or this is a rare word, it is repeating lesser, it is repeating more. So it will give some idea about the density or distribution of the given keyword in the documents. Okay, so term frequency, nothing but it try to find what the density or distribution of you can say there are some different terms. You can say frequency, you can say distribution, or repetition or occurrence of a given word in a given document, right? This is fine. Okay, now there's another term called inverse document frequency. Okay, so in the first part, in the TF part, what we were doing here in the TF part, suppose I have a word W, right? So I'm finding this word in a given document, suppose in D1, in D2, in D3, right? I'm trying to find the occurrence of word in document D1, in document D2, in document 3. So this occurrence is local, right? I'm finding the distribution in given document, so it's a local to that document. You getting my point? I have suppose three document, right? This word I'm finding in, suppose I have three document. I have a document D1, I have document D2, I have document 3. So this frequency is local to this document. Okay. Now I want to find the presentation of this word in a whole corpus. I mean, in whole uh, uh, entire document or entire set of data, or you can say corpus. I think this word you are familiar. If you are not familiar with this word, what is document, what is corpus, then maybe you have to watch my previous video. Okay, these are the common use which you use in the NLP world. Okay, so in a given corpus, in a given set of document, I want to find the importance of this word. Okay, so TF is finding importance of word in a given document, which is local to that document. But I want to find the frequency or importance of this word in a given whole corpus. Okay, so it measures how important a term is by reducing the weight or terms that occur frequently in a mini document. Okay, I will talk about it. Okay, but idea find that a word, uh, what is the frequency and how important that word in a given corpus. Okay, so that is the whole concept. Okay, there's a math behind that. Okay, let me remove this. There is a whole math behind that. How to calculate TF-IDF, there's a whole math behind that. Okay, I will cover the math. Okay, so but this is the whole intuition, my friend. What is TF, what is IDF? Okay, I hope you got the whole intuition. So again, let me repeat. So there are two terms, TF. Okay, so TF is the frequency of even given word, and let's suppose I have three document, so it is within the document we are finding the uh, distribution of frequency of given word in a given document. This is local to word. Okay, and IDF, we are finding the we are finding here we are finding this word in a given corpus. Okay, in a given corpus, not only local to document. Okay, so there are two things. Okay, so let us understand the maths behind it. Okay, and what is the importance in the machine learning perspective, I will talk about that. But this is the basic definition. Okay, and how to calculate. So these two words. Okay, first of all, let us learn that how to calculate TF, I mean how to find the frequency and how to find the IDF. Okay, let us understand that. Okay, and why IDF is very important. Okay, why we don't use only TF, why we have to use IDF along with TF. I will explain that. Okay, but let us understand the mathematical intuition, what is TF and what is IDF, how to calculate it. Okay, so it's very simple. Let me explain that. Let me remove this bunch of keywords from here. Okay, all right, we are all set. So now let me talk about TF. Okay, as I discussed, right, TF. So first of all, if you really want to understand this concept, I'm assuming that you understand what is document. Okay, what is document D? I hope you understand that. Then I'm always using corpus. Okay, I'm using corpus. Uh, yeah. So number of I mean corpus is equal to total number of documents. Total number of docs. It is called corpus. Okay, so I hope you understand what is document, what is corpus. Okay, now for example, to explain this, let's suppose I'm taking this example. Let me remove this just to explain you. Okay, this mathematical this mathematical formula. Let me use these three examples so it will be easy to explain this whole concept. Okay, all right, so let's suppose, my friend, I have three documents. I'm calling it D1. It is also called review, by the way, in NLP. So I'm calling it D1. This is my document 1, this is my document 2, and this is my document 3. Okay, so here I have three documents, right? I have three docs. Okay, and what is my corpus? So this whole thing, D1 plus D2 plus D3. Okay, this whole thing I'm calling it corpus. This is my corpus, corpus, corpus. This is my corpus. Okay, so this whole thing will be called as a corpus. This is my corpus, right? So now how to find TF? Suppose this is my given text, this is my corpus. With respect to this documents, let us find the TF. Okay, so TF is very simple. TF says that to find the TF, okay, TF of any given term in a document. Okay, how we find it? This is a formula. TF of what? TF of any keyword. T can be any keyword. Okay, in a given document. So TF is local to document. Okay, TF, we always find TF in a given document for a given keyword, so it is always local to document. Okay, so the formula is this. Okay, so formula is we divide two terms. Okay, in the numerator we say that what is the T, what is the frequency of T in the given D. I mean how many times the any keyword for which I want to find the term frequency is repeating in the given document. I mean, I just find the count of T in the given D, and then I divide by total terms in given T. Okay, for example, like this. For example, if I say that, let's suppose if I ask you, for example, for this keyword, let's suppose I pick up this keyword. Okay, so I want to calculate TF for keyword this. Okay, in document D1. Okay, so now tell me, so the in the numerator says that this word, how many times this keyword is repeating in this document. This pasta is stated just one time, so it's become 1, dividing by what is the total terms or total words in a given document. So I have 4 words, right? This pasta is tasty. I have 4 words, so I will divide by 4. So this become the term frequency of this keyword in document D1, right? Similarly, if I ask you TF for pasta, next word pasta in given document D1. Okay, so how many times pasta is repeating in this document? 1 time. So numerator is 1, dividing by what are your total words in document 4, 1 by 4. This is very simple, right? Similarly for each, 1 by 4, for tasty, 1 by 4. So this way we find that term frequency of each keyword in a given document. So you can see that the term frequency is local to document. This is what I wanted to explain in the beginning, right? Let me remove everything. I hope you got the whole intuition, right? So how to find the TF? It's very simple. TF is again, it is local to document. We find the frequency of given keyword in a document. Okay, this way we find the TF. I hope you got the whole idea how to find the TF. Okay, next is okay, let me calculate TF first. Okay, then I will go to IDF. Okay, so for example, let's again suppose this is my documents. This is my let's assume this is my D1 document, this is my D2 document, and this is my D3 document. Okay, so let us prepare a table for TF first, then I will go into IDF later. Okay, so here for given these documents, okay, so first what the step is, number one, what we'll do, okay, in order to find the TF for all the keyword. Okay, number one, this is number one. Okay, so number one, we build a vocab. I told, right, we build the vocab first. So given document D1, D2, D3, first we have to prepare a unique tokens, which is called vocabs. So what is my unique tokens, my friend? You can say this is there, pasta is there, is there, tasty is there, this already taken, I'm not repeating it, pasta already taken, is already there, not, so not is coming, tasty already there, this already taken, restaurant, serves, tasty already there, pasta already there. You can see that. So this is my unique tokens in a given document, in a given corpus. This is my, okay, let me remove this whole thing. I want to make it clean. I hope you understand how to build the vocab. This is a very important part. Okay, this is the first part, how to build the vocab. Okay, so this, for this documents, for this corpus, this is my list of vocab, right? Now this is my unique tokens, this is my all the unique keywords, these are my all keywords which are used in my given set of corpus, right? These are all the keywords. Now for each keywords I need to find the TF, right? I need to find the term frequency for even each keyword. So how to find that? So generally we prepare a table. Okay, we create a table like this, TF table. Okay, and in the column, okay, we have 3 columns because we have 3 documents, right? You can see that we have 3 documents, D1, D2, D3, right? So in the table we create 3 column. Okay, one for, this is D1, this is D2, this is D3. Okay, and one column for all the keyword. This is my keyword, right? So one column for keyword and another for all my documents. Okay, so my keyword is this: pasta is tasty, not, restaurant, serve. So this part is my what? This is my all keywords. This is my column 1. Okay, now for this keyword, this keyword, okay, I need to find the uh, term frequency. So in the D1, okay, so I told, right, term frequency is always local to document, always local to given reviews or document. Okay, so this keyword I will find in document 1. So I will find this keyword in all 3 document. What is the count of in D1, in D2, and in D3? Okay, so you can see that this keyword in D1, repeating what? One time. So numerator is 1, and what is the total word in this document? 4 words, so it is 1 by 4, right? For this in second document, okay, in the second document, which is this pasta is not tasty, what is the word, or what is the occurrence or number of distribution of this keyword? 1. It is repeating 1 time, so that is why in numerator it is 1, and in the denominator, what is the total words? 1, 2, 3, 4, 5, so it's coming 1 by 5. So this way we prepare a table. Okay, for example, this in the third document, again it is repeating 1 time, so in the numerator it is 1, and how many words are there? 1, 2, 3, 4, 5, so there was coming 5. I hope you got the whole intuition, right? So this way for each word, for example, for pasta, I will prepare the TF in document D1, in document D2, in D3, for each in document 1, 2, 3. This way I prepare the whole table of DF. I hope you got. It's very simple. Mathematically, this way we find it. Okay. Generally, you don't have to do this manual stuff. We have a model for this. Machine learning does everything for you. But here, I just wanted to explain the intuition first, how it is calculated. You don't have to do manual calculation. Okay. So this way we prepare our TF table for even all the vocab, for even given all the keywords. uh, I find all the frequency in a given documents. Okay, this way I come up with this nice table. Okay, so this table is called TF table. Okay, so I find that this keyword, I find this table. Okay, this is TF. Okay, now let me talk about IDF. Okay, how to find the IDF, right? So IDF, this is the formula for IDF. What we'll do, to find that, uh, okay, to find any keyword, to find the IDF of any keyword T in a given corpus. Okay, here small d denotes the documents like D1, D2, D3. Okay, and this whole thing as a combined D1 plus D2, D3, I'm giving its D. I'm calling it D, which is called corpus. Okay, that is what it is denoting. Okay, so if you are guys confused with this notation, so this notation is very simple. If I say TF T comma D, I mean I want to find this keyword T in a given document because it's a document specific. In the IDF case, I want to find that T, any keyword in a given corpus, in the, I mean whole document, in document 1, 2, 3, in the whole document. That is why I'm denoting it by letter D, which is nothing but, this D is nothing but my corpus, whole corpus. Okay, so the formula is N. So N is the number of documents, I mean my corpus. So you can see that what is the N here? What is the N here? Right? N in this case will be 3. So I have 3 document, D1, D2, D3. So number is 3 for N, right? And then in the uh, denominator, in the lower part, what I will do, I will divide this N by, uh, I will find that this T, okay, in how many documents this T are appearing. I will find the occurrence of given keyword in documents. Okay, I mean how many times this T is we able to find or locate in document, in how many document they are appearing. That is called the number. Okay, then we and in what in here what we'll do, we add one number. Okay, why we add one number, I will explain you. Okay, what happens sometimes, what happens, let's suppose, because, and here we apply a log. Okay, so let's suppose we find this number log. Let's suppose I have 3 documents. Let's suppose any term T. Okay, and I have total 3 documents, so N will be 3. Okay, let's suppose this T is repeating, I'm finding this T in all 3 documents. So what will be the occurrence? 3, right? I'm finding T in all D1, D2, D3. So what is the occurrence of T in given all the corpus in all document 3? So log 3 by 3 is become log 1, and log 1 is equal to 0. Okay, so in order to, because if you get a 0, so in order to, I don't want to get 0. Okay, so that is why I add a plus here to just avoid to getting 0, because I don't want get 0, because I have to multiply. Okay, generally what we do, we multiply TF and IDF. Okay, so let's suppose I got IDF 0, and if you multiply 0 with any number, it becomes 0. So this way I will not find any weightage of any keyword, though that keyword are repeating, that keywords are there in the document, but because of maths, because of log 1 becomes 0, I will find that there is no value of that keyword. Okay, so that I don't want that. Okay, that for that purpose, that is why we add one number to just avoid getting log 1 0. Okay, that's the whole purpose, right? So I hope you're getting this. Let me remove this. So this is where we find IDF. Okay, and IDF is it is not a document specific. We find IDF in a given whole document, all the corpus. Okay, so this way, let me now calculate the IDF part. Okay, again, so again for IDF, if you understand the formula, okay, again for IDF we will find a table. We will create a table for IDF as well. Okay, it's again very simple. Okay, so this is my IDF table. Okay, in IDF table I have a 3 column. First, actually only 2, we need only 2 columns basically. So in the first column is all my keywords. This is my keywords. Okay, my unique vocabulary on vocabs. Okay, and for given keywords, Okay, so we have to find the idea for given keyword in the whole document. It is not a document specific like in D1, D2, D3. Okay, we will find as a whole in a given corpus. Okay, so I will find the IDF. Okay, so the formula IDF is says what? Log. Okay, what is the total documents? 3. We have only 3 documents, right? And we have to add 1 and plus this keyword in how many documents. Okay, I repeat, this keyword in how many documents they are appearing. So let us see. So this is my document, right? This is my document. So let us see this keyword. Okay, let me remove this, then it will be easy to explain me. Let me, okay, now what I'm asking, I want to find that this keyword in how many document they are repeating. I can say that in document 1 they are repeating, there's a keyword. Even in the document 2 it is present. Even in the document 3 it is present. So it is repeating 3 times, right? So in given corpus, in given whole document, it, suppose my document size is 3, so in all document it is representing, it is available. So that is why here it will come like 3. You can see that uh, in the numerator I got 3 total number of documents. 1 I'm adding as a math says, and here this keyword are appearing in all 3 documents. That's why it's coming 3. Okay, so if we calculate log 3 by 4, so that is why for this keyword IDF in a whole document is log 3 by 4, which will come almost 0.000. Okay, uh, it is almost 0. Log 3 by 4 is 0. Okay, uh, let me calculate what is log 3 by 4. Let me ask ChatGPT. Log 3 by 4, calculate. It should not be, it is not 100% 0. It is not exactly 0. Okay, if it is log, if the base is 10, yeah, for actually in machine learning or in computer science, our the base of log is always we take e. Okay, so you can see that it is not exactly 0 here. Here it is not 0. It should be around this. Okay, it should be very close to 0. You can see that it's very close to 0 but not exactly 0. Okay, that is what, that is why I'm adding 1, right? That is the whole purpose. I'm adding 1 here just to avoid the 0. So it will not become exactly 0. It is almost very close to 0. Okay, you will never get 0. Okay, maybe it's very close to 0. We can see that it's very close to 0, but it is not exactly 0. Okay, it is 0.02 something like that. Okay, so this way you will you don't have to do manual calculation. Okay, uh, the machine learning model, the library will do everything. Okay, so this way friend we find the idea. Okay, for example, for pasta keyword I got 3 by 4. For each keyword log 3 by 3, 3 by 3. Okay, it's coming almost 0. Okay, each keyword. Okay, it's a filler word. Okay, so here I will get 3 and occurring 2 times. Okay, so it will become 0. Okay, no problem. Tasty, it is coming 3 by 4. Not, it is coming 3 by 2. Okay, restaurant, it is coming 3 by 2, almost 0.17. Serve is coming 0.17. Okay, so this way I hope you understand the maths behind it. This way we calculate table for IDF. Okay, so now I have the, now I have both. Okay, I have TF for every keyword. Okay, for every, for example restaurant keyword, right? So for the restaurant keyword you can see that for restaurant keyword the term frequency in document D1 is 0. It is not there. In document 2 also this keyword is not there. That is why it's coming 0. In document 3 it is there. It is coming 1.5. Okay, so you can see that this restaurant keyword, okay, this restaurant keyword is a rare word. It is not repeating frequently or most of the time. Okay, but you can see that this keyword, okay, this keyword, this keyword is repeating most of the time. It is also available in D1, D2, D3. Okay, this kind of word is called frequent word. It is called frequent word. Okay, so generally like filler word like a, and, the, is, these are called stop word, right? If you know the NLP, this is called a stop word. So generally the for the stop word, you will find most frequent word in a given document or in a given corpus. Okay, so here see, you can see that if you see the term if you just consider term frequency alone. Okay, so according to TF, you can see that for restaurant word, which is the rare word, its frequency is less. But for the this keyword, which is the stop word, maybe this has no much importance in my given text, its frequency is more. Okay, so somehow because this keyword is a stop word as per NLP, right? It does not carry any weightage. I'm not getting any context from this, from is, these, right? These are not very contextual word. It does not carry any weight. Okay, we can generally what we do, generally we remove this word. If you know that's NLP pattern, right? We remove all the stop word. But let's suppose we have this keyword, but these keyword are repeating most of the time according to TF, right? So somehow I want to penalize it, because if I don't penalize, okay, so my model will give you more weightage. This keyword will give more weightage. So my if I give more weightage to a stop word, so maybe my model will not perform well. The learning will be not good. Okay, so that is why I don't want to give more importance to this filler word or stop words. I want to reduce their weightage, and those words which are very rare word, okay, I want to give more weightage. So somehow I want to penalize this kind of a stop word, filler word from my given text, and I want to avoid rare word. Okay, so that is why we use IDF. If you multiply, what we'll do that after calculating TF separately and IDF separately, if you multiply, okay, TF IDF, generally this is you will find this observation. Okay, IDF, okay, IDF for rare word is higher generally, and idea for frequent word will be lesser. Okay, so here for example restaurant and serve, these are the rare words. It is repeating very less. The frequency is very less. It's a rare word, right? You can see that for the restaurant, if you find that, if you notice, for restaurant and serve, which is a rare word, IDF is higher. Okay, and generally these word like these, is, which are the stop word, their idea will be a bit lesser. They will have less idf, and for rare word their idf is more. Okay, so in the problem is in according to TF, in case of TF, these are rare word. According to TF alone, because these are rare word, their weightage is less, but IDF is giving more weightage, more value for those rare word. And if you combine, if you multiply both TF IDF together, right, so the value will be higher for rare words. Okay, so the multiplication of TF IDF will be higher for rare words, and for stop words like is, a, and that, it will be lesser. So this way, combining TF IDF, I'm giving more weightage to rare word, and I'm giving lesser weightage for stop word like a, and, the, is. These are because they don't carry any much weightage or more context. Okay, so this way it gives you weightage or importance. Okay, and this is why we find IDFs. So why we find IDF? If I summarize you, IDF, we with the help of IDF, we penalize. Okay, we penalize a frequent word and give more weightage, or we avoid. You can say we avoid the rare words. So that is why we use our TF IDF, and TF alone. It is, from the TF alone, it will not give good result. So that is why we combine IDF, and IDF will give more weightage for rare word, and it will penalize more frequent word. Okay, so this way my model will understand. My model will give more weightage for rare word because they are more. They will carry more context. This is a whole concept. Okay, so I hope you got the intuition, my friend. So let me remove this whole bunch of text. Okay, So this is what is the TF-IDF. This is all how we calculate mathematically. Again, you don't have to do this all mathematical calculation. We have a model, we have a machine learning model for this. It will done automatically behind the scene. But here but yes, you need to understand the intuition, the math behind it, how it works. What is the TF, what is the IDF, how it deal with the rare word, how it deal with the frequent word, why IDF is important, how it penalize the frequent word, how it award the rare word. This whole intuition you have to build. Okay, this is what I wanted to show you. Okay, so this is the mathematical calculation, right? So you can see that this is the conclusion. We will have higher IDF values, okay, because they are rare. So in the corpus, if some keywords are very rare, so they have higher IDF. The multiplication will be higher, but occurs in that document. Okay, so the crux is for the rare keywords, we will get higher TF-IDF, the multiplication, and the model will give more weightage for those keywords. That's the whole concept. Okay. But there again, TF-IDF, here, with the help of TF-IDF, we are trying to find the importance of any keyword. Okay, we will trying to under some context, but still it has some limitation. Okay, it is some, for example, semantic meaning. Okay, for example, if I'm using I like, I love, okay, these words are synonyms. Okay, so it is not apt to capture the semantic meaning. It is called semantic meaning. Okay, these two words are very like or very close to each other. So with the help of this technique, again, this technique is more like a keyword based. Okay, these are more like a keyword or more like a stats based. So this kind of technique is not able to capture the semantic meaning. So if you really want to capture the semantic meaning, we have to go with a different model, maybe word to wake. Okay, this is another model, word to wake. So word to wake model is a it was created by Google. So it is based on neural network. Okay, so this kind of model, word to wake model, it can capture the semantic meaning. My like word, love word, these words are more close to each other. How it works, that's a different thing. I'm not going to cover that, but it has the limitation. It is not able to capture the semantic meaning. Okay, even it's somehow it is not able to maintain the get the order context. Okay, and it is not good for deep understanding. Again, this has a lot of limitation. Generally we in the RAG application, okay, generally in the RAG application, if you want to perform dense search, we don't use this kind of model. But if you want to perform, this is very good for keyword based of search. Okay, suppose you have some keyword and you are not worried about sentiment semantic search. You're only worry about the keyword search. I want to get the exact match of this keyword in document. If you have this kind of scenario, exact keyword search kind of scenario, you can go with this kind of model because you don't need the semantic kind of searching, right? So in that case, it is very powerful, it is very useful. But yeah, these are some couple of limitation on this model. It is not able to capture semantic meaning, contextual meaning, and also another problem is that the result of this model, if you apply this model on your given text, okay, just like a bag of word, we have already seen, just like a bag of word, just like of n-gram, okay, it also create a sparse matrix. The result will be a sparse matrix, which is uh, which consume a lot of memory in the space. You will see a lot of zeros. Okay, if you prepare the matrix, I will show you. You will see a lot of zeros in that matrix. So it also produce sparse matrix, but these are some couple of limitations. Okay, so where will you use this TF-IDF? Okay, where it is got application? Let me show that. Okay, first it has a lot of implementation in the RAG application. I have seen that in the RAG application. Let me give some context. Uh, as I discussed in the beginning, if you want to build hybrid, it is called hybrid search functionality in the RAG application. Okay, if you want to build hybrid search, so hybrid search, it has two types of search. One is called semantic search, and one is called keyword search. Okay, so as for the semantic search, we use embedding model like word to wake other model. based on the vector database. Okay, in the keyword search, suppose you have a document and you want to find the exact match based on the keyword alone, only keyword alone, then you can use TF-IDF, this kind of technique. Okay, because it works very well on the keyword search. Okay, so you can combine both the semantic search or keyword based of search in your RAG pipeline. So where you can find use case. Okay, so document similarity, that's what I'm talking about. It is used in the RAG application. Okay, convert document to vector for cosine similarity. In the text classification, generally we use bag of words, this whole concept. You can find you can use this kind of model, this kind of technique. But yeah, but it has some limitation I discussed, right? Span detection, again, classification problem. Okay, search engine, yeah, in the search engine, if you want to, let's suppose a user gives some query, let's suppose tasty. Okay, tasty food, this is the query by any this is the query by user. Okay, and you have indexed a lot of document. You have document d1, d2, d3, d4, and in which document this keyword has more importance, where this keyword are repeating more time. Okay, if you have to build this kind of search, exact keyword search, okay, then you can use this kind of technique and it will give you good result with respect to exact. If you want, you are concerned only for the exact keyword match, it is also called lexical search. Okay, in that case you can go with that. So it has these are some importance. Okay, so I have seen in the RAG application we generally use this kind of model like BM25, TF-IDF for the keyword search. It is really, and we combine both the capability in hybrid search in RAG. Okay, so uh, these are the whole concept of TF-IDF. I hope you understand what is TF-IDF, what is the importance, what is the mathematical intuition, how to find it, and very important interview question. This question is asked. Generally, I have seen one interview question. People ask why we need IDF. Okay, why we need IDF? Why TF is not TF alone is not sufficient? Okay, and how it deal with rare word, how it deal with frequent word. Okay, these are some couple of interview questions they can ask you. Okay, so I hope you got the whole understanding how it deal with rare word, frequent word, but how the idea, okay, how we prepare this table. Okay, and where it can be used. Okay, so this video was mainly about all the basic concept. I wanted to build the basic intuition, what is TF-IDF, how it works. Okay, or practically how to use it in program, in Python, in machine learning. In next video I will cover about practically using this whole concept. Okay, so this is all in this video, my friend. I hope you got all the basic understanding what is TF-IDF, how it is, the intuition behind it, and where we can apply it, this concept. I hope you got the whole the idea. Okay, I will see you in the next video where I will give the practical example or practical application of using TF-IDF in a project. I will see you in the next video.